welcome back to yet another video on our channel Euclid Mathematics. We have started lecture series on JEE Mains, CET and other competitive exam. From few days we are solving the previous year question from JEE Advanced question paper. So in my today's video, I'm going to explain to you all one of the question which is from JEE Advanced question paper. So it is a very conceptual based question. So if we can feel that question, we can understand it very easily. Okay. So we have to go through some of the given first, then I'm going to explain to you all a complete answer. So now let's get started our today's question. I will explain to you all first question. So here in our question, we have given that a tau, okay, tau denotes the curve y which is equal to fx, which is on a first quadrant, okay, and 0.10 lie on it. So 10 point which is lies on that curve, that tau it is here. So 0.10 it is lies there on our tau. Means x is 1 and y is a 0. Okay, that means y, this is the equation for x-axis, y it is 0 there. Okay, so tangent tau at a point P intersect y-axis at yp. Pyp has a length 1. So P into yp has given length 1 for each point P on tau. So if we select any point on a tau, so we'll get the Pyp has a length, its length is 1. Then tangent to the curve y which is equal to fx at a point P of xy. Okay, so it is given in our question tangent to the curve y which is equal to fx at a point xy, and we have to figure it out which one of the option is correct between our 4 options. So now let's get started our today's solution. I will explain to you all in detail each and every step that how we can solve this example easily. So let's get started our today's solution. So here in our solution, first of all, we are trying to understand here what we have given. Okay, so we have given tau denote the curve y which is equal to fx, which is in a first quadrant and a 0.10 lie on it. Okay, so the curve which is coming from y which is equal to fx, which is in a first quadrant. Okay, that means the lesser value for that tau, it comes from 0.10. Okay, and the 10 point it is lie on it. Okay, so it is in first quadrant and the 0.10 it is on there on tangent. Okay, so tangent tau at a point P intersect y-axis. So it intersect y-axis. Tangent tau at a point P intersect y-axis at yp, and Pyp has a length 1 for each point P on tau. Okay, then tangent. So now here we try to remember the some result from application of a differential equation. When we have tangent to the curve, some curve like y which is equal to fx at a point xy, and the main curve at a point capital X capital Y. Okay, so we write y minus y which is equal to y dash of x into x minus x. How it is? Try to remember the equation of a tangent from the application of a differentiation chapter. That equation of a tangent, it says that y, if y, let y which is equal to fx be a curve and m which is equal to dy by dx at point x1 y1 be the slope at a point P of x1 y1, then we write equation of a tangent as y minus y1 which is equal to m into x minus x1. Okay, so m it is there as a dy by dx at a point x1 y1. So similar way, so as we have point capital X capital Y small x small y, so that's why I written this x1 y1 as capital X capital Y. Okay, so the equation of a tangent to the curve y which is equal to fx at a point P of xy small xy, I written here capital Y minus y which is equal to m. It is a differentiation, so I replace that m as y dash of x because our given curve y which is equal to fx it is here. So that's why, so y dash of x into x minus x here. Okay, intersect at a y-axis at a yp. Okay, so which intersect y-axis at a point yp. So if the line which intersect at a y-axis for some particular point, surely we know that the equation which is exists there, which always x is a 0. Okay, so if it is exists intersect at y-axis, then we say that the equation of x which comes 0. Okay, so if equation of x which comes 0, that means we have to substitute the value for x in our tangent, because point of x which does not lie there on our y-axis. So that's why for that particular intersection of that point, we write x is a 0. Okay, so if x is a 0, then we put value for x. Which x? But that point P of xy, that x is a 0. Okay, not that x. So capital X capital Y, these 2 points we have here are another point capital X and capital Y. So within that capital X is a 0. Okay, So if this x goes to 0, we left here with the value of a capital Y minus small y, which is equal to capital X is 0 minus small x into y dash of x. Okay, so this one is the value after intersection of this point. Okay, at point x is 0. So try to find out the value for capital Y. So capital Y, which is equal to positive y, take that y, it is here, so positive y minus x into y dash of x. Okay, so this is the value for capital Y of x. Okay, so here we can see capital Y is equal to y minus x into y dash of x, so which intersect at a point yp at a point x is a 0, so capital X is a 0 here. So I got the 2 point here for yp, where the point which intersect, which capital X is a 0 and capital Y, which is equal to y minus xy dash into x. Okay, this is all the thing which given in our question. We are trying to elaborate what we have in our question. And one more thing we have given, PYP has a length 1. Okay, so length of PYP, which is 1 given, and we want the distance between P of xy and yp at a point. I got the new point here, 0 x minus xy dash of x. Means what we have, length of a PYP is 1, means the distance between P and YP is 1. So let me explain here. So length of a PYP is 1. That means here the point P, which we have xy, and the point yp, I got it here as a 0 y minus xy dash of x. Okay, so we have length of a P and yp, which is a 1. Okay, so the point P is a xy, we know that, and yp it is here. So if length is 1, means the distance between these 2 points is 1. Okay, the distance between point P and point yp, which is 1. So distance between 2 point y means we use distance formula for finding the distance between 2 points. Okay, so the point P of xy and P of yp of 0 xy dash of x. Okay, so distance between these 2 points can be written as this minus this bracket square plus this minus this bracket square. Okay, so first point, x minus 0 bracket square, or you may write 0 minus x bracket square, plus y minus x y dash bracket square, or you may write y minus x y dash of x minus y bracket square. Okay, so take under square root, we are taking distance formula. How we use distance formula? So if we have point x1 y1 x2 y2, for finding their distance we use distance formula x2 minus x1 bracket square plus y2 minus y1 bracket square. Okay, so this one is a distance formula for finding the distance between 2 points. Okay, so similarly I applied that formula here for P of xy and yp of this point. Okay, so I got this one equation over here, and the length which is given 1. Okay, so square both sides, that square root will get cancelled and square of 1 always remain 1. So x square plus y minus y get cancelled, under bracket x into y dash of x bracket square. Okay, that means x square into y dash of x bracket square, which is equal to 1. Okay, so try to find out the value for y dash of x. As why we want y dash of x? Because in our options we have given our value for y of x or differentiation of a y dash of x. So we have to put this value front of our eyes, and then we have to follow our solution. Okay, so in our option, so we want the y of x and y dash of x. So for that try to go for detailed solution as per the option. Okay, so I got the value for y dash of x. After solving this equation, we get the y dash of x, which is equal to plus minus square root of 1 minus x square upon x. Okay, it is easier, just these are the easy calculation. Okay, so take this value here, 1 minus x square, it comes here, x square denominator here, take the square root, 1 minus x square, keep it same, and square get cancel. Okay, this is square here and it's 1 square, so taking square root of both terms, we land on this value. Now y, which is equal to yx. Now here we can see we have 2 values. Okay, most of the students they got the confused about the value for y dash of x. Okay, so as we know that if we have y which is equal to 5, which is a y square which is equal to 5. Okay, and we write y which is equal to square root of 5. Okay, y which is equal to square root of 5, but here we have 2 sign, plus and minus. That means plus 5 square is also 5, root 5 square is also 5, and minus root 5 square is also 5. So always remember, whenever we are taking square root of any number, we want the positive and negative sign also, because both of these signs gives us our actual value. Okay, so y dash of x I written here plus and minus 1 minus x square upon x. Okay, but one more condition we have given in our question, that is y of which is equal to y of x is a less in a first quadrant. Okay, and which passes to the tangent 1 0 if it is having less value. Okay, that means the derivative is a decreasing here. Okay, the derivative function, it is a decreasing here, and if it is a function decreasing, then derivative should be negative. So we have to pick the value for y dash of x is a minus of a square root 1 minus x square upon x. Why plus is not there? Because derivative of a function which is a decreasing, and if a function of a derivative is a decreasing, then we write our function in the form of a negative. Okay, so positive it will not come here, it is for increasing, and negative for decreasing. Here we all can see the tangent passes through 1 0, it has a decreasing function. If a derivative is a decreasing function, then derivative should be negative. So y dash of x, I got the negative of square root 1 minus x square upon x. Okay, so take this term here, take this term here, then we'll get the correct option, which is a c, which is x into y dash of x plus negative here 1 minus x square, which is equal to 0. So our option number c, which is a correct. Okay, c option is correct. So another option it is given negative here, so that one is goes to wrong. Okay, so now our next target is here to find out the value for yx. Okay, for finding the value of yx, it is a possible chances we have here, we can integrate this bracket. Okay, we can integrate y dash of x, then it is easier to get the value for yx. Okay, now it is the main task is here to integrate y dash of x. Okay, so as we can see, square root of 1 minus x square term is there. Under square root, we found some x square term like this, so we use a substitution under integral. Okay, so we use substitution for finding the integral. Now let's get started our finding the integration here. So y of x, I take an integration from the both sides, so differentiation integration, it will remain y of x, and integration over this bracket square root of 1 minus x square upon x. Okay, now so as we can see, under square root we have x square. Okay, so if we have square root x square under square root, then we use substitution result. Okay, and in integration chapter we learn already how can we substitute the values. Okay, so that's why we have to substitute x as a sine theta. Okay, so if x is a sine theta, then we can write dx is equal to cos theta d theta. Okay, x is a sine theta, then dx is a cos theta d theta. So y of x, okay, x sine theta, then dx is a cos theta d theta. Okay, so put value for x and put value for dx. Okay, so if we are putting the value for x, surely we have to go for the value for dx. Okay, so x is a sine theta, then differentiate both side dx, which is equal to sine theta differentiation cot theta, and differentiate that d theta. Okay, so which is a dx by d theta. Okay, so go for the further calculation. We have here y of x, okay, here, and square root of 1 minus x square, that means 1 minus sine square theta. Okay, and 1 minus sine square theta, what is the value for 1 minus sine square theta, which is a cos square theta. Okay, 1 minus sine square theta is a cos square theta, so I substitute this value here. 1 minus sine square theta is under square root cos square theta, x as a sine theta here. Okay, and dx, which is equal to cos theta d theta. Okay, so square root of cos square theta upon sine theta, cos square theta square root get cancelled, so cos theta upon sine theta. So again we get the cos square theta upon sine theta. Okay, so try to take it in the more simplest form. So integration we have here y of x, which is equal to negative of integration cos square get cancelled. Again we get the cos square term. Cos square is a 1 minus sine square, 1 minus sine square upon sine theta d theta. Because if we have u by v rule, like a by part of integration, that time it is quite confusing. But if we try to simplify our equation, which is algebraic or trigonometry, then it is easier to follow the further process. Okay, so we have to simplify it first, and then we'll move for further calculation. Okay, so 1 upon sine theta, which can be written as a cosec theta, negative of integration as it is, sine square theta upon sine theta, it remain negative of sine theta d theta. Okay, so it is easier for integration. So integration of a cosec theta, okay, log of cosec theta plus cot theta is there. Okay, under modulus it is coming, and integration of a sine theta, which is a cos negative of cos theta, and negative it get positive, and outside we have negative sign, it comes negative here. Okay, So negative sign it is coming for cosec theta also. So negative of cosec theta under coming modulus it will get vanishes. Okay, so here we can see negative under bracket it comes, it become negative cosec theta, and cosec theta it is having differentiation log of cosec theta into cot theta, but modulus here, so negative sign get absorbed. So negative negative is positive here, and sin theta integration it is negative cos theta. Okay, plus c. So I got the term for y of x, which is a log of modulus of cosec theta plus cot theta minus cos theta plus c. Now I got the value for y of x, but in our example, in our option, we have given our y of x term in the form of x and y, not in the form of theta, because we consider theta for just substitution only here. Okay, so we want our reverse process back. So substitute that theta again to the x. Okay, so cosec theta I can write it as 1 upon sin theta. Okay, why I'm writing here cosec theta as 1 upon sin theta? Because we substitute here sin theta as a x. We substituted already sin theta is x. So we want the value for sin theta x for substitution. So try to convert our whole term in the form of sin theta. So then it is easier to substitute the value of x. So cosec theta can be written as 1 upon sin theta. Cot theta can be written as cos upon sin. So 1 upon sin theta here into cos theta here minus cos theta plus c. Now our next target here to convert that cos theta into the sin theta. Okay. So we know that sin square theta plus cos square theta is 1. So cos square theta is equal to 1 minus sin square theta. Cos theta is equal to square root of 1 minus sin square theta. Okay. And sin theta is a x. Then sin square theta is a x square. Okay. So sin square theta is a x square. So cos theta can be substituted as 1 minus x square. Okay. And 1 upon sin theta means 1 upon x plus 1 upon x square root of 1 minus x square minus square root of 1 minus x square. Okay. Just these two values, this value and this value, substitute here. Okay. And we'll get the next step as, see here, next step. So I got the y which is equal to log of under modulus 1 upon x means 1 upon sin theta plus 1 upon x means 1 upon sin theta here, substitution, and a cos theta value here minus cos theta value here plus c. Okay, so we got the value for y of x in the form of a constant, but we do not want that constant here. Okay, so we have to find out the value for that constant. What we can substitute the value for constant, so we'll get the value for y of x. Okay, so here y of x it is here plus c. Okay, as we have point x is a 1 and y is a 0, if we substitute x is a 1, that means 1 minus 1 is 0, 1 upon 1 it is 1, log of 1 is 0, this term goes to 0. Okay, again y is a 0. Okay, y is a 0, this one is a 0, again 1 minus 1 it is a 0, so this 0, this 0, this 0, that means c, we got the value for a c which is a 0. If a c is a 0, then substitute here. Okay, if sub c is getting 0, we get the required value for y of x is a log of under bracket 1 plus square root of 1 minus x square upon x bracket complete minus square root of 1 minus x square, which is the required option number c. Okay, now see that how easy the solution it is. Just we have to apply application of a differentiation as a tangent of to the curve form, and then after that go for simplified the form of y of x. Okay, so if y dash of x is there and you want y of x, surely you have to integrate, because differentiation is the opposite of integration. So if you want the differentiation, differentiate it. If you want the integration, you have to cancel differentiation, then integrate it. Okay, so these processes are quite easy to understand. I hope you all have understood my today's lecture. It is completely based on differentiation integration chapter. It is easier to understand if you have basic concept proper and clear. Okay, so I hope you all have understood my today's lecture. Everything is it is easy. Even after, if you found anything difficult to understand, let me know in a comment section. I will come up with some other videos. So thank you everyone. Thank you for my today's lecture.